Hello, I'm Bhargav Sarvepalli. Me and my teammates are going to present our paper Cross-Lingual Sentiment Analysis using multilingual transformer models. I'll be taking care of the introduction part of our paper. So today, emotion detection is used in a lot of places like analyzing customer feedback, helping with mental health support, or even moderating social media. But most of these models are majorly trained on English datasets or any other well resourced languages. That means people using languages like Finnish, Swahili, or other low resource languages don't benefit as much from these tools. And with more people communicating in different languages online, we need emotion detection systems that can work well across many languages, not just English. So that's where our project comes in, where we are testing whether multilingual models like XLMR and Embed can handle emotion detection in a language they haven't seen during training. We also look at whether fine tuning the model on just English data can still help it perform better in other languages. So, these two questions guide our project. What sets our work apart is that we are not just building a model, we are comparing two very different strategies. First, we try to do zero shot learning, where we apply a model trained on English directly to another language like Finnish without giving it any training examples in that language. Then we try fine tuning, where we train the model on English emotion data and see if it still helps the model perform better in another language. We specifically chose Finnish because it's a low resource and structurally different language. This makes it a tough but different, interesting test case. So finally, the goal of our work is to provide practical guidance for building emotion detection systems that are scalable and fair, even when labeled data is limited in a new language.
Okay, so up next we have the related works. So in our study, we built on prior research using multilingual models like Embed and XLMR, which have proven to work well across different languages. So these models actually inspired a little confidence in our cross-lingual setup, especially in the zero shot classification, where the model predicts in one language it hasn't been seen the labeled data for. So we trained on English and tested on Finnish, like following the evidence that fine tuning actually improves low resource performance. So our data set choices, Go Emotions and XED were also informed by past studies for their emotional clarity and also multilingual benchmarks. So importantly, we use Marco F1 scores for fair evaluation and also across all emotional labels recommended by our previous research. So many of these studies actually highlighted the challenge of underperformance in low resource settings, which is directly motivated for an inclusive multilingual approach. So let's talk about why did we choose these papers for. So the papers actually talk about the same things that we're studying, like how to train in one language and test in another. So we picked both older important studies and newer ones to help us plan the work. So we didn't just look at accuracy. We also talked about real issues like bias and fairness. And this was what matches our goals to make emotion recognition better for less common languages. So these studies help us to see what was already been done and where we can add something new.
So coming to the methodologies, here we're going to discuss about the data sets and the procedures in this project. So coming to the data sets that we have used, here we can see that majorly our whole deal revolves around Go Emotions and XCD datasets. Talking about the Go Emotions dataset, it is taken from thousands of Reddit comments and it is mainly centered in English language. And the structure of this dataset is it has two columns, one is text and the other one is label. The whole range of emotions in this particular dataset is 27 emotions, and each integer is associated with each emotion. For example, here we can see that 27. 27 is for neutral. Likewise, 23 is for relief. For example, 11 is for disgust, and 14 is for fear. And coming to the XCD dataset, this dataset is also having English as well as Finnish in this, but for our use case, we have tailored this dataset to only take Finnish from it. Here also, we are having one column for sentence and the other column for labels. But unlike co-emotions dataset, this dataset is multi-label dataset. What that means, multi-label. Here we can see that in the label section, we see not only a single number, but a group of numbers, 1, 3, 7. What do they mean? They mean that this particular sentence is classified into three emotions, 1, 3, and 7. What is one? One is disgust, three is joy. Likewise, each and every emotion is linked with each and every number. In that way, there are only 7 emotions in XCD dataset and 27 emotions in Go emotion dataset. And coming to the models, what we have used, we mainly used 3 models. One is XLM Robota Large XLNI, and the other one is Embed, and the third one is XLM Robota Base. We're going to discuss about them further in the coming up slides. And let's talk about models architecture. Here we can see clearly that there are mainly two things happening in our project. One is zero shot and the other one is fine tuning. So what is zero shot and what is fine tuning? The concept of zero shot learning is that zero shot learning enables a model to perform a task without any labeled examples or training data for a specific task. What is fine tuning? Fine tuning involves retraining a pre-trained model on a smaller or a task specific data set to improve its performance on that particular task. So to tailor make these two concepts into our research questions, we have taken English and Finnish as our languages, and we have taken those three models and we have trained them on zero shot and fine tuning simultaneously. And to evaluate our scores, we have used macro F1 score and weighted F1 score. Let's see the key phases of implementation stages. Choosing the appropriate models. We have chosen those three models, particularly XLMR, XLNI in particular, which is tailored for zero-shot natural language interference tasks. Our selection aimed to contrast architectural strengths for Robota and Embed and zero-shot generalizations. Coming to valid single-label selections, we aligned both of our datasets in such a way that we can take 8-class emotion framework, which is common in both Go emotions and XCD. The common emotions are anger, anticipation, disgust, fear, joy, sadness, surprise, and trust. And these are selected in such a way that XCD emotion has multi-label classes, but we have only taken one label per one sentence. And this ensures the pre-processing and gives us a fair cross-lingual comparison and avoids label sparsity. And this is a crucial step in our model learning. And coming to fine-tuning, we did two phases of fine-tuning. In our first phase, we trained Embed and XLMR on English Go Emotions dataset and evaluated them on Finnish dataset. However, these models struggled to generalize effectively and gave us poor macro F1 scores around 0.05. What we think of the reason is this exposed a key flaw in our pipeline that could be an inadequate epochs or incorrect label to index mapping or inconsistency or noise in training data. So to rectify all these mistakes, we again redid all of this work in phase 2. What we did in phase 2 is we corrected label mappings to ensure consistency between datasets. We filtered we filtered what are the misaligned samples and we increased the number of training epochs. These controlled improvements significantly enhanced the model's learning capacity and boosted macro F1 scores to nearly 0.68. That is a great improvement. And I also want to mention that we didn't use XLMR, XLNI for fine tuning. The reason could be the limitations like access restrictions and lack of native support for fine tuning, or else the multi class emotion detection. Instead, we used it solely for zero classification, where it excels due to its NLA training.
Now we present the results of our cross-lingual emotion detection experiments using multilingual models. Our evaluation focuses on the performance of the models in both zero-shot and fine-tuned settings. Next slide, please. So here we show the zero-shot performance drops significantly when applied to Finnish, confirming that emotion classification does not transfer well across typologically distant languages like Finnish without adaptation. This means the blue bars show macro FN on English and green bars show macro FN on Finnish. For all three models, macro FN drops substantially on Finnish. This confirms that despite being multilingual, models need adaptation to generalize effectively to languages like Finnish. And here we can see that XLMR shows stronger FN scores across more emotions. And Embed also improves, but its overall FN scores are lower. Fine tuning on a high resource language like English helps models generalize better to finish, even without any finish specific fine tuning. This is what we can get from this graphs. And now we can see XLMR XNLI performs best in zero shot mode among all three models, likely due to its NLI focused pre-training, but still lags behind fine-tuned variants. So the bars compare per class F1 of three models for zero shot finish. XLMR XNLI outperforms Embirth and XLMR base in nearly every emotion class. Still, scores remain modest, highlighting limitations of zero shot inference. Although NLI pre training helps with cross lingual generalization, the model struggles with supple emotional expressions without fine tuning. And here in the slide 4, we can see that fine-tuning significantly improves emotion-wise FN scores across most categories. That means here in the graphical representation, we can see each line shows per class FN for different models. And the yellow dotted shows the zero shot Embed, green dotted line shows zero shot XLMR, red solid shows fine tune Embed, blue solid shows fine tune XLMR, and we can say that XLMR fine tuned shows best performance across all emotions. This demonstrates that cross-lingual transfer is most effective when models are adapted through supervised fine-tuning. Now we have the key takeaways and our next steps. We can see that these are our takeaways and the future work we are going to focus on. These findings from our project reflect the limitations of multilinguality without adaptation and highlight the importance of model choice and task-specific fine-tuning. This is our key takeaway from the project we have done. And the future work will focus on emotion detection models, more globally inclusive, and this will explore multilingual strategies and robust handling for rare emotion categories. Thank you so much.